nice sound. Okay, good morning, guys. Hope you had a good day yesterday. Tuesday today, so we'll be doing our maths lesson again. I've got the sound on everything. Sorry about that. Maths lesson today. You can see we're going to be doing 3D. It's 5 to, well, 4 minutes to now, so we're going to get started in 4 minutes or so. Good morning to everyone who's down. Good morning, Miss Carthy, just seen there in the chat. Mrs. Carthy, sorry. Morning, Amelia. Morning, Lucas. Milo, I've seen. Morning, Ollie. Morning, Maisie, I think I saw. Morning, Maya. Morning, Tom. Lots of people down already. Been down there for a while and chatting. Morning, Francis. Morning, Claire. Drew, Ben, Scott. Okay, lots of people down there, so good morning to you. Sorry if I missed you. Okay, the chat's going by quite quick at the minute. We're going to get started in 3 minutes or so. Remember, you need something to write with. You need some paper, and we will get started soon. Hope the picture quality is a little bit better than yesterday. I realised some of my lighting was off yesterday, so hopefully we'll be able to see everything today. So 3 minutes or so, and we're going to get started. Okay, a couple of minutes and we will get started at 10 o'clock. Just get everyone a chance to get down. Right, okay, let's have a look. It is 10 o'clock there, so we are going to get started, okay? Welcome down, everyone. I can see by the views, it looks like there's a few more people in than normal. I did see that English Martyrs did just tweet out saying, inviting the pupils to come along and watch a few from English Martyrs. good morning. My school when I was in a primary school, so you're welcome along, everyone is. It is Tuesday, so we're going to be doing maths. A couple of things to go over in case you are new. In the chat, please, we're going to be asking questions. We're going to be talking about the maths that we are doing. Please try and keep it in the chat about that. If you keep spamming things all the time or distracting other people because you're having conversations and things like that. Some of the teachers who are moderating in the chat might time you out or hide you from the chat. We don't want to do that, okay? It's just to make sure that people who are really trying to do the work are getting on. It's great to see you chatting before and good to see you and have a little chat afterwards. And we'll keep it for that. As a lesson, if there is anything you need help with, you can pop it in the chat. We might catch it, but if you put it as a comment on the video, we will definitely catch it. Maybe not during the lesson, but afterwards we will contact you. Or if you are struggling with anything, you can contact me on my socials, which Facebook, Mr. Biggins123, Instagram, Mr. Biggins123, and Twitter, Mr. Biggins123. So they're all up there, you can get in contact. And we have worksheets and things that link with the lesson for afterwards. They're going to be downstairs, down under the video in the description. So I was pointing down, I'm thinking of downstairs. Okay, you can put in help, ask for help on there if you want. So loads of different ways to get into contact with us. Now, I put all that up and then I've just realised when I check it, we always start our lesson with a fluent in 5, okay? Which is to wake our brains up, get our mathematical brains going. And basically give you 5 minutes to have a go at 5 questions. Okay, I'm going to start writing the questions on the board. As soon as I've finished writing the first question, I will pop the timer on. Okay, you're just going to do these on a piece of paper and we'll go on through the answers afterwards. Obviously you can see today I'm not going to go through the answers in much detail because I don't have much space, but there are videos on my channel that will help you if there's any you don't understand. So if there's any that you don't know how to do or you forgot or you can't remember because it's been a while, have a go at them. But if you're really struggling, you can leave them and we'll talk about how to do them afterwards. So we're going to start with our fluent in 5. Okay, and I'll do these in black because I know yesterday we had a difficulty with some of the lighter colours. So as soon as I wrote question 1, you can start having a go at it. And I'm going to do it, put the timer on. So your first one is 965 times 56. 965 times 56. I'm going to start my timer now. Okay, so the timer started, and I'll write your other questions up as we are waiting. So 965 times 56. 3,658 divided by 16. 5/20. 5/20 plus 2/20 plus 3/20. 3/4 plus 3/4. Trying to move my head out of the way, I'm probably getting complaints. Not an addition there. I've set it up for you just because I ran out of space. And your last question, running out of space. So you got 3.5 minutes left there. Have a go at them. Remember, don't worry if you don't know any of them. It could be a while since you've done some of these concepts. Just do what you can. If you think you've sort of got an idea, just have a go at that. And if you're really struggling, don't stress about it, leave it out, and I'll tell you how we can work it out in a little bit. Okay. Just checking the chat in case there's anything people can't see. Bell's pencil's not working. Bell, if you run out of time because your pencil's not sharpening, don't be putting messages in the chat. Hi Zachary, hope you haven't got the questions. 6 questions. I'll tell you how long you have left. Have a quick look. 2 minutes, 10 seconds-ish. 2 minutes, 10 seconds-ish. Hi Conrad. Well done Emily. If you're done, double check your answers. Anyone that's finished there, Kira, C, Ellie saying that you are done. Double check your answers. Don't worry if you're not. We all work at different pace. You still have about 1:10 left, so that's enough time to do a couple more questions and also enough time to double check your answers. Remember, when you're double checking, double check all your working as well, not just the answer. Well done those finishing with 1 minute left, but remember, if you finish with 1 minute left and then you made a silly mistake, it's not good when you've had enough time to have a check of it, okay? If yours is blurry and you can't see much, okay? Can't see it's coming through okay for most people. You might want to pause it a little bit and you'll be a little bit behind the lesson, okay? And the chat will be a little bit behind, but it should buffer a little bit so you can see it a bit better, all right? Morning, Jake. Nice little emojis there. And you got just under 10 seconds, so you want to be finishing off your question. Okay. 4, 3, 2, and 1. Okay, that's your time to stop. Put your pencils down there now. Now you can see normally I might go through the answers a little bit, but I don't have any space, okay, because I've got my 3D shapes up. So what I'm going to do, I'm just going to give you each answer, and I might give you a brief description of how we do it, and let you know how to find out how to do those questions if you are struggling, okay? So your first one was some long multiplication. There is a video on my channel which tells you how to do long multiplication if you're unsure, but your answer should have been 5, 4, 0, 4, 0, okay? 54,040, all right? 54,040. If you're unsure, you got wrong or anything like that with your multiplication, haven't got enough space really to get done there, so you can have a look in the on my YouTube channel in the math section, okay? There are some videos. Question 2, okay? Question 2. Okay, Mrs. Carthy saying there's quite a few people struggling with question 2, so I'll see if I've got enough room with this to do this one. So we had, let's rub this other one out and give us some more space. If you did this one, brilliant. If not, don't worry about it. So we had 3,658 divided by 16. Okay. So the first thing I'm going to do is I'm going to start writing my multiples of 16, and that's what we do when we've got divided by a number that we sort of don't know the times tables for. So I'm going to start writing them here. So I've got 16. Okay. And there's multiple ways you can do it, whichever way is best for you, but I'm going to add my 10s then my 1s. I'm going to add 10, then I'm going to add 6 rather than just trying to add 16 or counting on 16 because I'm more likely to make a mistake. So if I add 10, I've got 26, then add another 6 on, I've got 32. Okay, then I'm going to add another 16, so I'm writing my multiples. So basically I'm writing my 16 times table here. I'm writing my multiples of 16. Add 10, 42, add 6, 48. Now I'm going to stop there, okay? The reason I'm going to stop there for the minute is when I look here, I can see that my first two digits there are 3 and 6, okay? Now I know 16 is not going to go into 3. We always know when we're dividing by a 2-digit number, we move straight on to 2 digits, okay? Because a 2-digit number is never going to be smaller than a 1-digit number. So I know it's going to be 36, so I know I went over 36, so I'm not going to keep doing my 16 times table. I might have to in a little bit, okay? But I can see that I went over 36, so I'm going to stop there for now, so I'm being efficient. And I need to see how many 16s are in 36. Well, I can fit 2 in there. I can fit 2. I'm not going to put that 0 because we wouldn't really put it on. I can fit 2 in, but it would only get us to 32. So how many more to 36? 33, 34, 35, 36. Okay, so I've got 1, 2, 3, 4. So I need to carry over my 4. What I do is cross them out as we go along so I don't get mixed up. So now I've got 45, yeah? So I need to see how many 16s are in 45, okay? And if we check how many 16s in 45, let's have a look. We've got 1, we've got 2, we can't go to 3, can we? Now this is where sometimes people get confused because they say, oh well, 48 is close to 45, they put it in. 48 is bigger than 45, isn't it? Okay, so we can't have 3. So again, it's going to be 2. But at 2, I'm only at 32. So now I need to count on to 45 to see how many that I would have left. So if I'm at 32, 10 to 42, and 43, 44, 45. So I've got 13 left there. Okay. Okay. So now I've got 138 and I need to see how many 16s are in 138. Now I haven't got space to do all my multiples, okay? Now I know that 116 times 10 is going to be 160, isn't it? So I might start to work my way back, okay? So I'm going to roll up my, you could keep going down all the way until you get to a number. But what I'm going to do there now is I'm going to try and think a bit smarter and say, well, I know that 10 times 16 must be 160. So let's see what 9 would be, okay? So if we take off 10, 150, and then take off 6, 144, okay? Again, I need to go back another one to see whether I could do that. So I'm going to take off 10, so I'd have 134, and then take off 6, so I'd have 128. Okay, now I can see 138 sits in between 8 and 9. Okay, 9 is too many, so it must be 8 here. Okay, but I'm only at 128, so I need to see how many have I got left. 128 to 138 is an easy one for us. We can see it's 10 more on, so I have 10 left over. Now that was a really difficult one. That was probably the most difficult one on there. Okay, but 228 remained at 10 is your answer. If you're still thinking, oh, I still don't really know how to do that, again, there is a video on my channel on how to do long division, and you can have a look at that. Sorry, short division. You can check that after the video if you need. Okay, thank you, Mrs. Carthy, for letting me know there's a few people struggling with that one, and I hope that's helped a little bit if you can. We'll do the other answers a little bit quicker. We had our 20ths. They were all, okay, 20th, so we just had to add the numerators together. So 10 20ths was your answer. If you simplified that to a half, give yourself a pat on the back, okay? Both answers are right. Both would get your mark in the in a test where, let's say, arithmetic test at SATs. If you were doing it, there would be both answers would be accepted. However, if it said simplify your answer or give your answer in the simplest form, you'd have to have a half, so you can have a tick if you've got 10 20ths or 1 half, okay? And let's have a look. Question number 4. When we had 3/4, add 3/4, okay? Question number 4 was 3/4 plus 3/4, so you can have 6/4, okay? I will accept that as an answer. Or you might have changed that into a mixed number, 2 2/4, or you might have put it into a mixed number and simplified it, so 2 1/2. So you've got 2 1/2, give yourself 2 pats on the back. If you've got 2 2/4, give yourself a pat on the back. If you've got 6/4, give yourself a thumbs up, okay? All those answers are the right. Okay, now that might seem confusing, but that's because they all show the same thing. Okay, it's different ways of showing the same number. If your answer just said, what's the answer? You could have any. If it said simplify it, we'd have to simplify it to a half, or if it said leave it in a mixed number, we'd have to change it to a mixed number. Again, if you're not sure about those, I have a video on mixed numbers, fractions, and improper fractions, okay? Your next one was an addition. 7233 was your answer. Question 5, your answer was 72,333. Okay, that was your answer for question 5. And your last one was, okay, we had 5,000 times 3. So what I'm going to do is I'm going to do 5 times 3. Okay, 5 times 3 is 15, and then I'm going to put my 3 zeros back on. Okay, so a quick way to do it, if you knew your 3 times table or your 5 times table, you could get that one nice and quickly by just taking the zeros off, putting zeros back on. Okay, so good time to good way to wake up the brain. Okay, if there was somewhere that you were unsure of, that's good, because it means that you are learning things. Okay, never think I don't know what that means, this is bad. Think I don't know what that means, that's good, because I'm in a lesson learning about it. Okay, I always find it strange when people go, oh no, I've got a lesson on this, I'm not very good at that. You should be cheering because you're doing something that you need more help with. So that is great. So today, if you hadn't already realised by the title of the video, my tweets, my things out, and all of them behind me, we are going to be looking at 3D shapes, okay? And we're going to look at the names of 3D shapes and how we describe them, their properties, okay? So we use the word properties to describe the things that make that shape what it is. So there are 3 basic properties that we look at in a 3D shape. And they are the face, okay, they are the edges, and they are the vertex or vertices. Okay, so it's vertex when there's 1, vertices when there are 2, and I've wrote it there because you can see that we changed the spelling slightly when we put it on. Now these definitions you might want to write down because they will help you. Okay, so the face is a flat surface on a shape. Okay, so I'll pop this down in your notes. Flat surface. Okay, so if I've got a 3D shape here, my shreddies, well, my fiance shreddies, okay, this flat surface here is a face. Okay, that's a face. So they come in different shapes. Okay, but it's a flat surface on a shape, and that's what we call a face. May as well keep that. Now, an edge is what it sounds like. It is an edge, but if you want to describe it, it's where 2 faces meet. I don't mean kissing. Okay, I mean look, that face there meets that face. So there's an edge, okay, but we know what an edge is because we describe edges all the time in real life. So we've got face there. So where they meet, that is an edge, okay? You've got a face there and a face there, and where they meet, it creates an edge. So those are edges, okay? And the last one, your vertex or your vertices, is where 2 or more edges meet. And what I always add on the end there is the way that it's easy to remember is a corner. Okay, so these corners here on the shape, you can see there's 3 edges there coming in, and where they meet, it creates a vertex. Okay, or this, obviously we have lots of them, so we have vertices. Okay, so where more than one edge comes in, it creates a vertex. Okay, so a corner, and that's the easy way to remember them. So I'll be writing those down because those, if someone says how many vertices this shape have, or how many vertices does this shape have, how many edges, you need to know what they mean. Okay, now some of them are easy to remember, some of them find them a little bit harder, but that's absolutely fine. So we use these three properties in order to describe shapes. Now, what we're going to do today is I've drawn lots on the board and we're going to go through them, and we're going to go through them one at a time. And as I go through them, I'm going to tell you about their properties. And I want you to write down, okay, the name of the shape and the properties as we go. Now, after the lesson, when you get the worksheet, there is a PowerPoint that has, or a PDF, I think it's been made into, I'm not sure, that has all the pictures of these shapes on, drawn better than I've drawn them, okay, easier to see, and you can have a go at drawing them then, okay, but I wouldn't draw them during the lesson because you're going to probably take you a while. It took me a while to do these this morning, and you'll get behind a little bit, okay? So write the name of the shape, the properties, maybe leave a little space to do a picture. You can re-watch the video afterwards and start drawing the pictures, or you can have a look at the PowerPoint and the PDF and do them, okay? So that's what we're going to do today, to start off with, sorry, I'm conscious of taking a drink of water now because my mum watched my lesson yesterday and thought I was poorly because I kept drinking water. So I'm okay, mum. She just cares about me. So we're going to go through the shapes. As I say the shape, write it down and we'll talk about them. But as we're going as well, what I want you to do is think mathematically. Think like mathematicians. Because afterwards, I'm going to start asking some questions about, are there any rules that you've seen, maybe about the names of them and the types of shape, how we work out how many edges and corners they have. So as we're going through the shape, really listen, don't just pop them down, okay, and think, can I think of any rules? Is there any things that are the same? Is there anything patterns that I notice? Okay, so we're going to start with the one that we know. Now, it's always hard because we're trying to draw a 3D shape in 2D, okay, so we know sometimes there's things behind. I do have blue lines on some of them which show sides that are behind, but that's just on shapes where I think we needed it. A cube, okay, we a lot of us know, recognize a cube and would know that one, QUBE, okay. Now if we're talking about the three different properties, it has 6 square faces, so all the faces on a cube are the same, okay, they're all squares, so I guess they're all the same size. And it has 12 edges that are all the same length. Because all the sides are squares means, remember, all the sides of a square are the same size, it means every edge is the same length. So it has 12 edges and they are all the same length, okay? So remember what edges along here. Now it's hard sometimes because you get asked about edges on a cube, and if we look at this, we can go 1, 2, 3, 4, 5, 6, 7, 8, 9. It only looks like there's 9, but remember, when we're looking at this picture, it is just a representation, and we actually have some sides behind. So we have, okay, this is if we could see through the cube, or if it was see through, okay, and you can see that goes back there. Now we have the other 3 sides that we could see. If you had an actual cube, it would be easier, okay, you could count them, but it has 12 edges, and it has 8 vertices, okay, so 8 corners, 1, 2, 3, 4, and then we have 4 on the bottom as well. So it has 8 vertices. The next shape we're going to look at is a cuboid or rectangular prism. Okay, they are the same. I double and triple checked and everything online this morning because I've always thought this, but I've always doubted that it could be the same thing. But a cuboid, C-U-B-O-I-D, and rectangular prism are the same thing. Now, this one has 6 rectangular faces, okay? So the faces on here are not squares, okay? Obviously, because if they were squares, it would be a cube. And the 12 edges, the same as a cube, okay, but these are not all the same. So rectangular prism, or a cuboid, has 12 edges, the same as a cube, okay? But they're not all the same. The same way a square has 4 sides and a rectangle has 4 sides, but the squares are all the same, the rectangles are not all the same, okay? And again, it has 8 vertices, 8 corners, okay, the same as the cuboid. Okay, now I'm going to move over here while we look at our next shape for you to pop down is a cone, okay? I'm going to put that on, okay? So the next one that we are looking at, okay, sorry, I've just seen someone distracting other people. Okay, sorry about that. So we have a cone. Now this one's hard to draw because it would be like, imagine an ice cream cone, okay, one of the ones that sort of goes up and has the curve on, like the ones you get with the Italian, really nice Italian ice creams, okay, and it had a flat bottom there. So the cone goes up to a point, but has a circle on the bottom, so it has one edge, okay, and that's on the bottom where the circle, okay, meets the top of the cone. Okay, so you have there, and you have the circle on the bottom. That has the one edge. The cone only has one edge, but it has two faces because it has the circular face on the bottom, okay, and then has the curved face that goes around the outside. Now it doesn't have an edge, okay, sorry, a vertex. Now this is one where it's a little bit strange because we have the tip of the cone, don't we? But that's not a vertex because remember, a vertex is where two or more edges meet. This shape only has one edge, so it can't have a vertex. What we call that point is an apex, okay? So it has one apex, and this is the only shape that we're looking at today that has an apex, and that is where they meet, okay? So we have the curve, it's like a curved pyramid really, with our circle on the bottom. We have the point which is a apex. So that is a cone, okay, and you'll, again, a cone is one that you recognise. So wait until we get over to here is the ones that you might not know the names of. This one is a sphere, and the sphere is basically like a ball, okay, but it's perfectly round, okay. So remember when we, if you were in my science lesson, we talked about spherical objects and oblate spheroids and things like that. Okay, those shapes are not sort of perfect spheres. Perfect sphere means the diameter, so the length across is the same, okay, the diameter goes through the middle, is the same everywhere on the triangle. So perfect sort of globe shape would be a sphere, okay, anything else is spherical, okay, and has one curved face, okay, so just the whole circle around there will be one curved face. So because this has no edges and it has no vertices, okay, and obviously it's perfectly rounded. Okay. So, next one we're going to move on to. So you should have 1, 2, 3, 4 shapes down there now. The next shape that we are going to look at is the triangular prism. Now this is the one where we might start trying to think of rules. Okay. Prisms is the one where there are lots of sort of rules for. There's a few prisms we're going to look at. So as we're going through, see what patterns you notice about the prisms. So a triangular prism. Now it's called triangular prism because we have a triangle on the end, and it's sort of as if that triangle has been stretched out, and we have the same triangle would be on the other side. So if I had my blue pen, which I do, okay, it would sort of go, oh, just doing this rough, which is why I said maybe check the pictures afterwards. Okay, we would have the same triangle on the other side. So these two triangles will be the same. So it has 5 faces, okay? It has 1, 2, 3, then one on the bottom, 4, and one on the other side, 5. And we have 2 triangular faces, 2 triangles. So the 2 ends are triangles, but the rest are all rectangles. So you have your 2 triangles on the end, and the rest are all rectangles, okay? It has 6 vertices, 3 on this side, 1, 2, 3, and 3 on that side, 1, 2, 3, the 3 points of each triangle. So it has 6 vertices, 6 corners, and then it has 9 edges. So we have 3 here for the triangle, 3 there for that triangle, and then 3 edges that join the triangle up as it's stretched back, okay? And that is a triangular prism. Now, a triangular prism will go from here and get stretched back, okay? So you can have different types of triangular prism. You can have different triangles on the end, okay, so the triangles on each side need to be the same, but I could have a shorter one, I could have a bigger triangle, okay, and they could be longer or they could be shorter, okay, so this isn't the only triangular prism you could have. As long as it has these properties, it is a triangular prism, but there are different types of triangular prism, okay. Next one we have is a square-based pyramid, okay, and it's called that because we have a square base and then the pyramid shape we know because of the Great Pyramids in Egypt. Most people know what it is. So it has 4 triangular faces, Okay, so 1, 2, 3, 4 that go around, that go to a point. So 4 triangular faces that go to a point, but it has 5 faces in total because it has the square face on the bottom. Okay, so we have the 4 triangles and the 1 square on the bottom. And it has our 5 vertices. So we have the 4 corners at the bottom of the square, and then we obviously have the 1 point. Now this one is different from the cone because we actually have edges going in. So this isn't an apex, this is a vertex, okay? Because on here, we don't have 2 edges coming together because we have no edges. Here we have actually 4 edges coming together, so where they meet becomes one of our vertices. So there's 5 vertices, and there are 8 edges. So we have our 4 on the bottom, and then our 4 that go up to make the point. Okay, so you should have 1, 2, 3, 4, 5, 6 down there now at the minute. Don't worry if you're trying to keep up with your writing and stuff like that. You can just make rough as notes and things. I'm trying to not go too fast so you can get them written down. Next one, we're going to look at a cylinder. Now, a cylinder has 2 circular faces. Okay, so we have one on the top here, one at the bottom. Obviously, we can't see. If we did have, could see through the shape, okay, it would sort of have that circle bottom, wouldn't it? Okay, so we have 2 circles, one on either side, and it has 1 curved face round. So although here, okay, these look like edges, it's just because on the 3D shape, you can imagine a cylinder, most people know a cylinder, it goes all the way around. So when we're looking at it, you can see the edges, but when you feel it, it's a curved face, okay? So it has the 2 circles and the curved face. So 3 faces in total, 2 circles and 1 curved that goes round and joins them. It has no vertices because there is no point where 2 edges meet. Okay, because we have this circle at the top, so that's 1 edge. Then we have the 1 edge at the bottom. Okay, and because there's those two curved edges that don't meet each other, there are no vertices. Okay, so there are only 2 edges and no vertices at all. Okay, if you look at this in a picture or you're looking at this in an exam question or anything like that, don't count these 2 as edges, because remember that's just because of how we're looking at the curve. They normally add shading onto it so you can see it's sort of a curved shape, which I've tried to add with some of them, otherwise it would just look like a circle. Okay, now we're going to move on to a shape that you might not know the name of, and that is a tetrahedron. Okay, this one brings out my Scottish accent. Tetrahedron. Okay, so tetrahedron. Okay, I can see a few people getting timed out in the chat there. Mrs. Carthy there and Miss Allison having to time people out. Make sure you're keeping on task. You should be trying to watch these. People need to ask questions in the chat, so don't be popping loads of stuff in the chat there. Okay, so tetrahedron. Now a tetrahedron is made up of 4 triangular faces. So it might look like this one, okay, when we look at it like that, but had it in your hand and it was 3D, the bottom face is not a square, but it's a triangle. So it has 4 triangular faces. Okay, so it's a pyramid with a triangle on the bottom, and it has 4 vertices. Okay, and 1, 2, 3 points on the bottom with having a triangular bottom. Okay, and 1 at the top, and it has 6 edges. So our 3 edges on the bottom triangle at the bottom, and then our 3 edges that come up to make our point at the top. Okay, and that is a tetrahedron. And next one, I'm going to do another prism. So this is the third if we include the rectangular prism that we're looking at. So this is where we're starting to think, can we see any pattern starting to form? So this is a pentagonal prism. Now, pentagonal prism gives us a little clue about it in its name. It says pentagonal. Okay, it has 2 faces that are pentagons, this side and the other side here, that will be on the back. That will be 2 pentagons, and then we have 5 rectangles that go around that join those up. Okay, so we have 2 pentagons and 5, so it has 7 faces in total, 2 pentagons, 5 rectangles. And because this has 15 edges, so we've got our 5 here for our pentagon, our 5 on the other side for the pentagon, and 5 sides going down that join them up. So in total, it comes to 15 edges. And then we have 10 vertices, 10 corners, because we've got a point, 1, 2, 3, 4, 5 on this side, then another pentagon on the other side. so we've got 5 on that side as well. Okay, so that is a pentagonal prism. Now we're going to move on to a hexagonal prism. Okay, very similar. When we talk through it, you will see, because this one, pentagonal prism, pentagon on either side, hexagonal prism, you guessed it, hexagon on this side, so 1, 2, 3, 4, 5, 6 sides, hexagon on the other side, and then 6 rectangles that join them. So it has 8 faces in total. Okay, one more, because obviously there's one more rectangle needed because there's an extra side in there. 8 faces, 2 hexagons, and 6 rectangles as our faces, and we have 18 edges. Okay, so we have 6 here for this one, we have 6 on the other side, and then we have 6 that obviously join them up, and then we have 12 vertices. So we have 6 on this side, okay, 6 on the other side. Altogether comes to 12. Okay, and then octagonal prism, you guessed it, octagon on either side, so we have 2 octagons, but because there's 8 sides, it means we need 8 rectangles down the middle, down here, to join them. Okay, so we have 10 faces in total, 2 octagons, 10 rectangles. So in total, that gives us 24 edges. Okay, 8 on this side, 8 joining them, and 8 on that side. Okay, and 16 vertices. 16 on this side, 16 on that side. Okay, I'm going to just take a little minute, because I did go through those last ones, a couple of quick, make sure people got the notes. Like I said, don't try and draw the pictures, especially these ones. You can see my pictures are going a little bit skew with. Don't try and draw the pictures, try and do those maybe after the lesson, okay? Because remember, if you've just got the properties down, it's best to see a picture to really understand how that shape goes, but do it after the lesson for me, or else you'll fall behind, okay? So we had an octagonal prism, but now we've got an octahedron. Now an octahedron has 8 triangular faces. So the oct in octahedron is telling us that it's got 8 faces, and they're all triangles. So we've got 2 here, then the other side. So it's like a little sort of diamond type shape. And the best way to describe it, if you've played on The Sims, is like the little thing that comes above the head. Okay, so all the faces are triangles. We have edges going around and 6 vertices. Okay, so we have 1, 2, 3, 4 vertices here, and then we have the 2 points, which make it 6. Then we have the edges going around. A dodecahedron, this one here, which was the hardest one to draw, took me ages, still doesn't look very good, does it? Okay, dodecahedron has 12 pentagonal faces, so it basically has 12 faces that are all pentagons that are the same. Okay, so they look different on there, the pentagons, but it's because obviously your perspective. Imagine if I was looking at it, okay, that pentagon would look different because it's going in a different direction, but if I turned it, all the pentagons would be the same. It's called a dodecahedron. The dodeca means 12. Okay, remember when we looked at 2D shapes, a dodecagon was a 12-sided shape. Okay, so it's 12 pentagons together. Okay, and it has 30 edges and 20 vertices. Okay, it takes ages to describe all them. Okay, but we can just pop them down. We know 30 edges and 20 vertices, 20 points. Okay, and the last one, well, one of the last, yeah, basically the last one that we're looking at is a hexagonal pyramid. Okay, hexagonal pyramids. Okay, remember pyramids, we can all see it going up into that point, like the pyramids do in Egypt. That's how we can remember what they look like. But a hexagonal pyramid has a hexagon on the bottom. Okay, sorry, or a pentagon has a hexagon on the bottom. All right, so I'm going to get my pen. So our pen. So it has a hexagon on the bottom and then 5 triangles, because remember, a hexagon has 5 sides, so we need 5 triangles to go up. Okay, so whatever shape's on the bottom, you're going to need those to go up, don't you? Okay, and has 6 vertices. One I couldn't fit on was a pentagonal prism, but I thought I don't have to go into a pentagonal prism. Okay, I'll write it up here if you want it. I'll rub these off. If you want to pop this one down, and there is a picture on the with the work, so you can have a look at it if you want and can draw one, but I'll write the word for you. So pentagonal As you could guess, hexagonal pyramid, square-based pyramid, a pentagonal pyramid has a pentagon on the bottom, and then it has the 5 triangular faces going up. Okay, so it has 6 faces, and that means it has 10 edges and 6 vertices. Okay, so those are the shapes that we are going over. Okay, if you've had any problems, if it's out of buffer or anything like that, just pause the video, refresh it, something like that, and you can catch up. If you didn't get all these down, don't worry as well. You can watch the video again afterwards, okay, and catch the ones that you didn't get. But what I want to ask you now is your first thing of thinking is, have you noticed any rules or have you noticed any patterns that would help us when we are thinking about 3D shapes? Let's talk about prisms first, okay? We've got a rectangular prism, a triangular prism, a octagonal prism, hexagonal prism, pentagonal prism, okay? So let's think about prisms. They must all be called prisms for a reason. Okay, there must be some rule or something that makes them prisms. So in the chat, can you pop down have you noticed anything about the prisms? How would you describe a prism? So if I said to you, what's a prism? Okay, not a triangular prism or a octagonal or pentagonal. What is a prism just in general? Okay, can anyone think of what that might be? So have a look. Okay, if you can't think now, have a look at those shapes. We've got a triangular one there. What do they have in common? A pentagonal prism, a hexagonal prism, okay, an octagonal prism. So we've got all these prisms. What do we notice about them? Okay, let's have a look there. Sarah, really good description of it there. Okay, Sarah has said that a prism is an elongated, I like that word, an elongated form of a shape. Okay, so what she means there is, if I said to you, we've got an octagonal prism, it means you have an octagon on the end, and then it's been sort of stretched out, elongated, okay? And then we obviously have the octagon on the other side because we stretched it out. And that's the same for everyone. If we have a look, a pentagonal prism, it's a pentagon on the end, and then it's stretched out. Okay, we have a hexagonal prism, we have a hexagon on the end, and it's stretched out. Could be, it might be small, it might be bigger, okay, but it is stretched out to make it 3D, okay? And again, a rectangular prism or a cuboid, it's a rectangle on the end, isn't it? And it's as if it's been pulled and stretched, okay? So we have that rectangle there on this 3D shape, okay? And it goes, it's like it's been pulled and it's all the way there, then it means that's the same rectangle, isn't it? Okay, because it's been pulled back. So that's what a prism is. I think it was Sarah got in with that one. There's some other people there popping some things in. But that's really good. That's how to describe prisms. So if someone said to you a shape that we haven't looked at, okay, so we didn't look at a nonagonal prism, okay, it would have a nonagon on the side and be pulled back, wouldn't it? A 9-sided shape, okay. A heptagonal prism would be a heptagon and pulled back, isn't it? So we don't need to know and remember what all of the prisms look like, because we can work out that if it's a whatever prism, it's just an elongation of that shape. So that's really, really good. And, okay, Ollie, that definitely looks like it's been Googled, okay? I would, if you Google an answer and you copy and paste it, please, please, please try and put it in your own words, or it's obvious to see, okay? Good try though, mate. Right, so I've just said there, if we didn't know about then we could find them. There is actually a way to find out how many edges and how many vertices a prism has without actually having to work out and count them. Okay? Can anyone think of it and pop it in the chat? So I'm going to start thinking, right, okay, so for my edges on my triangle, I'm going to talk through, I'm going to see if anyone can pop on the rule on there. If I've got a triangular prism, I've got, let's start with edges. I've got 9 edges, so I've got my 3 for my triangle here, 3 for my other triangle, then 3 joining them. Okay, that comes to 9. If I've got my pentagonal prism, I've got 15 edges. I've got 5 for my pentagon, 5 on my other pentagon, and 5 joining them. Can you see a pattern starting? Octagon. I've got 24 edges. 8 on this side, 8 on the other side, and 8 joining them. Hexagonal. We have got 18 edges. We've got 6 here, 6 on the other side, and then 6 that join them up. Okay, can anyone see a rule? Okay, can anyone see how we can work out how many edges a prism has without actually having to count them, okay, or having that shape inside? Let's have a look. I'm just checking the chat. Okay. Brilliant, Amelie. The first one in there. It is the amount of sides on the shape times by 3, okay? Triangle has 3 sides. So 3 times 3 is 9, okay? Hexagon has 6 sides. 6 times 3, 18. Octagon has 8 sides. 8 times 3, 24, okay? Rectangle has 4 sides. 4 times 3 is 12, okay? So that tells us the edges, because we're obviously going to have the amount of sides there, then times 2 would be the other side, then times 3 would be the edges that you need to do it. And we can do the same with the vertices on a prism, okay? So the vertices on a prism, all we have to do is multiply the sides on the shape times 2. Triangle, 3 sides, so it has 6 vertices. A rectangle has 4 sides, so it has 8 vertices. Hexagon has 6 sides, so it has 12 vertices, because the 4 points are the 4 points of the shape, and we have 2 of them, okay? So we can see there how we can work it out. And it's the same with pyramids as well. We had a square-based pyramid, hexagonal pyramid, and we talked about a pentagonal pyramid. A pyramid is where they meet up to a point in triangles, but the bottom of it will be the shape that you mentioned. Okay, so we had hexagonal. If you had an octagonal pyramid, it would have an octagon on the bottom and 8 up. So we don't have to know what all the shapes look like and remember them. All we need to do is remember rules for prisms, rules for pyramids, things like that, and it can make it easier for you. Now, I'm going to rub these off, and what we're going to start talking about is nets. In the chat, does anyone know what a net is? Now, I don't mean going out to catch a fish in the pond, okay? I don't mean a net to catch mosquitoes or anything like that. When we're talking mathematical, what is a net? Just for time, I'm just going to leave those ones there. Remember, if there's some that you haven't got the details down for, or it was a bit blurry, when you watch the video back, it will have buffered and it should be fine, or they're all on the worksheet, okay? So what is a net, okay? Can anyone describe what it is? Because, again, a net's a difficult thing to do, because we're trying to talk about 3D things in 2D, okay? The net of a shape, yes, Stephen, that's what I've just asked. What is the net of a shape? So you've said net of a shape. What is that? I'm going to start drawing the net of a cube, and you can maybe, if you don't know what a net is, start thinking. Okay. Imagine these are all cubes that are the same size. For speed, I'm not going to measure them all. My sides are really quite wanted here. So this is a net of a cube. Okay, so net's linked to 3D shapes. Okay, again, Amelie, you're on fire today. Okay, Freya as well, I can see there. Extiolo. Well done, Claire. Don't worry, Ruby, if you need the shapes, you can watch the video back, and they're all on the worksheets that there's a link to in the bottom. So don't worry, okay. Some people are talking like a broken down shape, and best way to talk about it is an unfolded shape, because the things that we actually use and are used a lot in sort of production and things like that. So I've been talking about this box for a while. If I folded all of those sides up, imagine this is was a piece of paper and I made them, it's easy to see. I folded that up and I folded that up and I folded that and I folded that and the next one over, I would make a cube. So I'm going to try and not break this box too much. I'll go on the seams. And this is really handy, and it's things that we use in real life because companies use them to make shapes and to make things because it's easier than sticking 1, 2, 3 pieces of paper or card or something together to make a shape. Okay, I'm just going to hope this doesn't tear. So this box here, let me see if there's any other box that you have with food or cereal and stuff in, mostly in there. You can see that was a cube, but when I unfold it, okay, we have all the different rectangles, okay, and they're all there. Now, these rectangles again when I fold it, so that's my 3D shape, and my net is when I unfold it, okay. So I have all of my faces. So this is why it's handy to know about how many faces a shape has, because I know 1, 2, 3, 4, 5, 6. Cube has 6 faces, so this I'd have to have 6 faces for that. Now you can't just put them in any way that you want. If I moved, we had 6 faces, and I moved one of the faces to there, okay, that wouldn't fold to make a cube. So they have to be able to fold to make the shape. So I'm going to draw a net on the board now, and I want you to tell me, okay, what shape you think if we folded this up, it would make. Okay, if it wasn't wonky. So I'm going to put that R's in there to tell you the rectangles and S's in here because I've drawn that quite quick. So if I folded those together, what shape would that make? Okay. If I had okay, thank you, Miss Allison. I was just about to do that. Okay, if I had that shape, what would it make? But I'm getting 2 answers there because when we just look at the shape there are technically 2 answers. Okay. And if we have a look at this one, it is a rectangle. Now, I'm going to show you why this is a little bit different now. Okay. But it is a rectangular prism, or it is a cuboid. If I folded these sides up, it would make them. Now, don't worry if you find this hard. It just takes practice and practice, because you have to visualize in your head these sides moving up, okay, without being obviously able to see them. Let's do another one then. What would this be the net of? So if I fold these sides together, okay, imagine that's a square, okay, because I know it's a little bit off, and then we have our triangles around the outside. Now don't be put off by them, still in the chat please. Pop down what shape that you think this is. Well done, Ruby. Jasmine, if you've made notes, go back through. You might be able to have a think of the properties. What faces do we have? We have a square face. We have 4 triangular faces. So what 3D shape had those properties? So if you can't visualize it folding, think about the properties. And that's why it seems silly to remember them, but it helps us with other things sometimes. Well done, Claire. Well done, Alex. Not a cone, since I can remember a cone has a circle on the bottom, doesn't it? Okay. Then it only has 1 curved face. This has 4 faces, 4 triangular faces. Well done, Kira. Well done, Sarah. Well done, Leah. Going back to see who was one of the first ones to get it. Here, mine, not a triangle. Remember, triangle is a 2D shape, okay? So it's a 3D shape. Remember, if we fold it, it will become a 3D shape, okay? So this is what most people are putting on there, okay? This is called a square base pyramid, okay? So you imagine this square bottom is the base of it, and if we folded these up, it would go into a pyramid. Now, the reason I put on these things here, okay, was to try and see if it would put you off. What do we think these things are here? These little edges that I've put on. Why do you think I've put those on? And with my rectangular, okay, if you have a look, there are some on here. So these here don't need to be there. Okay, and we've got one on the edge. Those two don't need to be there. Okay, to fold it and make it there. So what are these things for? Okay, why have I drawn these on? Why have I drawn those on? What do we think they are? Well done, Emily. Yeah. Yeah, well done, Sarah, as well. It's to get them to stick together. Okay. These are little flaps. Okay, that we would put the glue on and would be inside the shape. If we didn't have those, we would fold it, but there would only be the thin edge to stick together. So when we have nets, we tend to have these little flaps on in order to join them up and to stick them together. Okay. 2 more questions and then we are going to end the lesson. So I'm going to draw, no, 1 more lesson actually. So Mrs. Carthy says a tetrahedron has a net made up of 4 triangles. Okay. Oh. Miss Allison says she has now I want you to answer this question. I want you to tell me who is right, but I also want you to explain as well. So if you had this question, this is a question you might get on shapes, okay? So it might not just say how many faces does a tetrahedron have or anything like that. Okay. It might put as a reasoning question like this to try and confuse us. However, this is really quite a simple question, and this is what normally happens with reasoning and problem solving questions, is to try and make things more difficult than just asking us something. But really the maths and the things that we need to know are quite simple. So who is right? Miss Allison and Miss Carthy? And if it said why, what would you have to put? So who is right? Is it Mrs. Carthy or is it Miss Allison? Okay, and I think some people might be guessing this just because they know me. Oh! I think Mr. B's the one that's wrong, okay? In fact, Mrs. Carthy actually corrected me there, okay? So it looks like Mr. B is wrong. So I'll pop up here Mr. B is wrong, but who was wrong now? That was a little test, make sure you were awake. Okay, well done, Milo. Well, Evie, yes, both of them were, but there's one right now. So, in this question, okay, is Miss Allison that is right. You would just say Miss Allison is right because tetrahedron is made up of 4 triangles together, okay? So this is how you might see the questions worded. Don't be worried by them or don't be distracted by them, okay? It's still just a simple maths that we need to know. So that's our lesson for today. And like I said, what I would do is with your notes, first thing, I would draw examples of the 3D shapes. It might be hard when you first try. Just give it a go, okay? And put them down next to your notes. And then there are some questions on there. And they're not just for today, some questions for the next couple of days, all to do with 3D shapes and the properties and things like that, reasoning, problem solving, some really good ones up there. The link to them is in the description. Okay, there's a year 5 link and a year 6 link. So if you click on those and you can go to the worksheets, then you can do some work to catch up on this one. Okay. So if you need any help, pop it in the comments for me, okay? If you need any help, go to my socials, Mr. Biggs123, Facebook, Instagram, Twitter, or if you need any help, pop them on the Padlet. There's so many ways to get in contact with us. If you do need help, people do, most days, okay? Ask us little questions, things like that, and that's absolutely fine, okay? We are here to help support you. Try and come and ask us first for your parents. Give them a little bit of time off, okay? Because they're working too, probably. Anyway, that's it for today. I'm going to stay around for 5 minutes or so. Make sure everyone's okay. You can ask me some questions in the chat if you need to. But apart from that, just let you know there's going to be 2 lessons tomorrow. There is no lesson on Thursday. I am in school again looking after key worker children. So I'm going to do 2 lessons tomorrow. Science in the morning and still looking at space. And in the afternoon, we're going to do an art lesson. Okay. For the art lesson, you're going to need paints is best. If you don't have paints, felt tips is probably your next best thing. You could do it with pencils, but it would take you a long time. Okay, so felt tips if you have to, but paints will be best. Okay, so that's for tomorrow. So if you're heading off, enjoy that, and see you tomorrow, hopefully. If you stay around the chat, you can ask me a question if you are stuck on anything. Okay. Or the lessons tomorrow, Sarah. The science one is 10 o'clock, same as then. And then the afternoon lesson will be at 2 o'clock. Okay. Isabel, let's think. For tomorrow, watercolour is probably going to be the best paint. Okay. You're welcome, Vinny. Bye, Amelia. Bye, Lola. You're welcome. Bye, Eleanor. Bye, Iris. Lovely letters there. You too, Joshua, I think I saw. Bye, Sarah. It was great to see you in the lesson. You're welcome, Nee. You're welcome, you and I. See you later. Tom, if you want to, you can pop one in and see if I can get it. Yeah, maybe if you need to watch it again, some of the properties and something, that's absolutely fine. See you later for now. Ellie, I'm going to try is a big thing and get it out today. If not, I'll try and get it tomorrow. See you later, Pranjal. Right, okay, I'm going to leave it there. I'm going to head off. Looks like there's not many questions on them, on what we've done in the lesson. So that's great. But if you do have them, remember comments get in contact any way that you want, socials or anything like that. Good luck with the work. Like I said, there's another week's worth of work on the Padlet there if you need it. So not just some photo today, or you could do it all today after today's lesson. But hopefully see you tomorrow. Like I said, 10 a.m. for science in the morning, and 2 o'clock in the afternoon for some art. Okay, and you'll need some paint for that. Okay. Really help me out as you go on. If you just give the video a like, sorry. Subscribe if you haven't already. Keep up to date with the lessons that I'm doing, and share it with anyone that you think could help. I see there was a lot of new people in there today. If you think you could help them, share it with them, and let's help as many people out as we can with these lessons. Okay. See you tomorrow. Have a good day.